All right, good morning, good afternoon, good evening. It's Blisszystitches once again on your screen, and I want to welcome you. If this is the first time you're coming across my channel, please do well to like, share, and subscribe, and most importantly, turn on the notification bell so that you would get to know whenever we upload a new video. So now this is a continuation of a previous video that's already on the channel, and I'm going to drop the link on the description box below. And it's also a requested video from one of my students who is in the offline class, and this popped up, so I have to address it by coming here to do a video so every other person can benefit from it. And I'm going to use the easy and the simplest terms you've ever come across with. To the returning subscribers, you are so much welcome. You're the reason why we're doing this. And the new subscribers, well, we love you all. This is Blisszystitches once again. Let's get into the video. Now, we understand that tape measures comes with different forms of decimal points. I love to call them calibrations. And then we have the 16, the 8, the 32, whichever one you buy. Okay, whichever one you buy, just be sure that you understand how to interpret them, how to apply them into your measurement. Okay, and whichever one you are conversant with, I would advise you stick to that one. If you're working with the 8-point calibration and it's working for you, please stick to that. You work with the 16 and it works for you, stick to that. Same with 32. But I love to stick with these two because I know how to maneuver it anytime in my own favor and understanding. So now we have the 8-point calibrated tape measure. I don't have the 16, but I have drawn the sample on the board right there, as you can see. All right, so we will be making use of it. You're not going to be missing out. If I can find a picture somewhere, I'm going to drop it along the line on the screen. But if I cannot, we would basically just move on with the one that I have on the board. Now, we know that there is what we call equivalent fraction. And if you're conversant with how equivalent fraction works, you're going to see that your tape measures basically makes use of equivalent fraction. Now, the numbers that you have on the denominator can basically divide itself with, and also the number that you have on the numerator can also divide itself, right? So in a situation where you are working with calibrations that have numbers that cannot divide itself, what you have to do is to subtract. Okay, you would have to subtract to get a number that can divide itself. All right, now I'm going to be dealing with the 8-point calibration first so you can understand the markings. But before we do that, let me cite this as a take home, like a point for you to hold on to. The difference between the 16-point calibrated tape and the 8-point calibrated tape is just the decimal point. A decimal point in between. That is the difference. The difference between the 8-point calibrated tape rule, sorry about that, and the 16-point calibrated tape rule is with the decimal point in between. What do I mean by that? Does it really make sense? Let's go to the board. Now, take for instance that this is my 8-point calibrated tape rule, right? And then I have the 1/8 as the first point on the tape rule, which is this. Let me use 1 inch other than using 0, right? On the board is 0, but let me use this. Makes a lot of points, so let me start with this. If you see this decimal point after one whole number here, right? Take for instance that this is 0. The decimal point after here is what we refer to as 1/8, right? The next one here is what we refer to as 1/4, want to be sure. The next one here is what we refer to as 3/8, so on and so forth till you get to the last point, which gives you the next whole number, and is 2 inches. So that's exactly what I'm about to explain here on the board. So when I mention, you know that I'm talking about each point in between. Now, from where you have your 1 or your 0 to 2, or where you have your 1 to 2, just take note of that. So now 1/8 here is the first point, the first decimal point on the 8-point calibrated tape rule. 1/4 is the second point, or the second decimal point on the 8-point calibrated tape rule. The third point here is the decimal point, is 3/8, and this is the third decimal point on the 8 calibrated tape rule. The fourth one here is referred to as 1/2, which is also known as half, and it is the fourth point on the 8 calibrated tape rule. The fifth one here is the fifth decimal point, known as 5/8 on the 8th calibrated tape rule. The next one is 3/4, and it is the 6th point, okay, on the 8th calibrated tape rule. Why is it referred to as 3/4? You're going to see that as we progress. The seventh one is known as 7/8, and it is the 7th decimal point on the 8th calibrated tape rule. Then you have this, obviously, which has to be a point until all other point is included before it becomes a whole number. But without other decimal point, it is also a point by itself. Now, this is actually going to make it an inch, right? This is for the 8-point calibrated tape measure. Of course, we've discussed that. And now I want to pull you through how we arrived with all these calibrations, all these points, in a very simple term so it would not be confusing. Now, take for instance, these are two whole numbers. Of course, without the points, they are also referred to as points. But when it has other points, this is my method, I refer to it as a whole number. Now, two whole numbers divided by 2 makes half, right? And then we have our 1/2 here, okay? And then a half divided by 2 gives us a quarter. So now what you're going to do is you mark the quarter. Now each of those quarter has a name. So you call it 1/4 and 3/4. 1/4 towards the metallic side of the tape rule, and then the 3/4 towards the inches continuation, right? So now the quarters 2 divided has other numbers, and they are called the 8. So you have 1, 2, 3, and 4. These are the 8. 1, 2, 3, and 4. Now we call this the 8. So you have 1/8, 3/8, 5/8, 7/8, and then one whole number. Now this is how you can, understand the calibration move on your tape rules. Understand that the two longest lines represent the whole number. Those two longest lines divided by half, okay, divided into 2 is what gives you half, which is the 1/2. And then the half divided by 2 gives you a quarter, which is 1/4 or 3/4. Now the quarter divided by 2 gives you 8, okay? It gives you 8. So you have 1/8, 3/8, 5/8, and 7/8. Now remember, at the beginning of the video I said that the difference between the 16-point calibrated tape measure and the 8-point calibrated tape measure is just in 1 decimal point. The difference is with a decimal point. Now that leads us to this side of the tape, the board, which has the 16-point calibrated tape rule. Now if you look at this calibration, you're going to see that this is 1/16, right? The next one is 1/8. And then you look at this side, the first one is 1/8. The difference between this and this is with the 1/16. So now let's continue. You have 1/6 and then 1/8. Now on the 8-point calibrated tape rule, we said that 1 point away from the whole number is known as 1/8. Now this is going to be 2 points away from the whole number is 1/8. That is on the 16-point calibrated tape rule. 2 numbers away from the whole number, or 2 points away from the whole number, is 1/8. 4 points away from the whole number is 1/4. On the 8-point calibrated tape rule, 4 points away from the whole number is half, which is 1/2. So let's count this. This is 8 points, rather 8 points away from the whole number is going to give you a half. So let's count 1, 2, 3, 4, 5, 6, 7, and then 8. So this is 1/2, right? But here we have 1, 2, 3, and then 4, giving us 1/2 here. So the difference is a decimal point away from the whole number. All right. So now, how do you understand further if you're not going to be using that method where you understand that 2 points away from the whole number is 1/8 for a 16-point calibrated tape rule, and then 1 point away from the whole number is 1/8 on the 8-point calibrated tape rule. Then 4 point makes half of an inch on the 8-point calibrated tape rule, but 8 point makes half of an inch on the 16-point calibrated tape rule. All right. If you don't want to use that method, you can say that 1 decimal point after the other before you have the same calibration with this other one. Okay, I hope I'm not confusing you. All right, a quarter on the 8-point calibrated tape rule is 2 decimal points away from the whole number. The quarter on the 16-point calibrated tape rule is 4 points away from the whole number. Do you understand now? So let's move on. When we're talking about the calibration on a tape rule, it has its own fraction, and for the 8-point calibrated tape rule, right, this is what we call the fraction: 1/8, 3/8, 5/8, 7/8, 3/4, 1/2, 1/4. All right. Now on the 16-point calibrated tape rule, it also have the same, but this time around the numbers tend to change or increases because of the multiple decimal points found in between a whole number, right? So now we have 1/16, 1/8, 3/16, 1/4, 5/16, 3/8, right? 7/16, 1/2, 9/16, 5/8, 11/16, 3/4, 13/16, 7/8, 15/16, and then 1 inch. Now we had to count that much before we get to 1 inch from the 0 point, but here we only had 1/8, 1/4, 3/8, 1/2, 5/8, 3/4, 7/8, and then 1 inch. You can see that we counted 8 points before the whole number, and here we counted 16 points. All right, 6 making it an inch. All right, here 8 points makes it an inch, here 16 points makes it an inch. All right, so now we are going to be trying to see if we can actually, I numbered this at the beginning of this video because of a reason, because I want to show you something. Now this is numbered 1 to 16. 1 to 16. The same way this is numbered 1 to 8. All right. But here there is a calculation I want you to see so it won't sound obvious. On the fractions that we have when we're referring to the 16-point calibrated tape rule, looking at this numbering, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. And I know some people are going to be asking questions like, why do we have 1/16, 2/16, 3/16, and when it's supposed to be 4/16, we're not having 1/4, all right? When it's supposed to be 8/16, we're having 1/2, which represents a half. This is quarter, this is half. And why do we have 3/4, right? 3/4, when we're supposed to be having 12/16? Why do we have 7/8 when we're supposed to be having 14/16, right? Why do we have a whole number, right? This is 2 inches, right? So I'm going to answer you that question. When we say that 9/16 is the same as you would have said 8/16, which equals a half, we are not making mistakes. All we need to do is show working for you to understand how we got here. So now, talking about equivalent fraction, it means you have to divide the number on the numerator by itself, right? And also the number on the denominator by itself, meaning whatsoever number you're dividing, it should be able to give you an equal proportion, right? like I said, why do we have 1 over 4 instead of 4 over 16? 8 1 over 2 instead of 8 over 16, and so on and so forth. I want to prove to you that if we say 9 over 16, it is the same as we would have said 8 over 16, which equals 1 over 2. All right, apparently that is a half. And if we say that it is 3 over 4, right, other than saying 12 over 16, we also have a reason, because I'm going to prove to you how we got here. And if we say 5 over 8, other than saying 10 over 16, I'm also going to make the mathematics clear for you to see why we term this 5 over 8 other than 10 over 16. Because when you're counting, it's supposed to be 1 over 16, 2 over 16, and so on and so forth till you get to your 16 over 16, which is apparently going to be 2 inches. So let's start the calculation. First, we have 1 over 4. I definitely did not calculate this, but when you divide 16 by 4, that is definitely going to give you 1 over 4, which is a quarter, right? That means a quarter. 1 divided by 2 is a half. Half divided by 2 is a quarter. So if you do 16 divided by 4, this is 16 over 6 over 16, right? This is exactly what I wrote before now. And then I also raised it to tell you that this is supposed to be 3 over 8, right? But let's see how 6 over 16 has automatically become 3 over 8. So you say 6 divided by 16. And like I said, equivalent fraction, definitely. 16 divided by 2 is going to give you 8, right? 6 divided by 2 gives you 3. And that automatically gives you 3 over 8. All right? I feel that is solved. The next one is half. And I'm like, why do we say that 9 over 16 equals half? In the real, it doesn't really make sense. But let's see how we can solve that. So when you say that the number cannot divide itself, what you're going to do here is minus, right? You need to subtract. So we say 9 minus 1, and that is 8. So 8 over 16, or 8 divided by 16. Let's see how that can turn to 1 over 2, which is equals a half. You now say 8 divided by 16. Again, you're going to bring in the fraction. 16 divided by 2 is 8. 8 divided by 2 is 4. So we say 4 over 8. And now you continue. You say 4 divided by 2 gives you 2. 8 divided by 2 gives you 4. And you have 2 over 4, right? It doesn't still stop there. You go ahead and you say 2 divided by 2 equals 1. 4 divided by 2 equals 2. And that gives you half, 1 over 2. And that's how we now said that 9 over 16 is equivalent as saying 8 over 16, which equals 1 over 2, a half. So let's move on. And then we say, instead of calling it 10 over 16, we rather choose to call it 5 over 8. And how did you get that? Because it's not making sense. We now want to multiply, because at this point you need to multiply. We say 5 divided by 8 first. And then we also did the same thing we did for the division. We say 5 times 2 is 10, and 8 times 2 is 16. So that gives you 10 over 16. The next one is 3 over 4. We're going to do the same thing, the multiplication method as well. How come that we're not having 12 over 16, but rather we're having 3 over 4? So we want to explain that. 3 times 4, you're going to do 3 divided by 4 first, and then you're going to multiply the denominator, and you're going to multiply the numerator. So 3 times 4 gives you 12, and then 4 times 4 gives you 16. And you know the rest is history. All right, so this is how you can actually, calculate the fractions on your 16-point calibration. And always let this sit in your mind that the difference between the 8-point calibrated tape rule and the 16-point calibrated tape rule is just with 1 decimal point. And where you have 2 points away from the whole number, making 1 over 8, you have 1 point away from the whole number, having 1 over 8 on the 8-point calibrated tape rule. Where you have 4 inches away from, 4 decimal points away from the whole number, to have 1 over 2, which is half of an inch, on the 8 calibrated tape rule, or the 8-point calibrated tape rule. On the 16-point calibrated tape rule, you're going to be counting 8 points away from the whole number to have your 1 divided by 2, which is a half. Okay, where you're going to be counting 8 points to have an inch on this other side, which is the 8 calibrated tape rule, you're going to be having 16 points to make an inch on the 16 calibrated tape rule. So I hope this is simple enough for us to understand. The same is applicable when you are dealing with a 13-point calibrated tape rule. The difference too is with the decimal point, right? For that one is going to be the difference between the 16 calibrated tape rule and the 32 calibrated tape rule is with 2 decimal points, and so on and so forth. But how are you going to be putting this into use? You want to stick around, because when we get to our basic bodies drafting, you're going to see how we can apply the 2 different tapes into our basic bodies drafting, and you're going to see how we would use it and the differences between one and the other. All right, where you're supposed to be marking if you're making use of a 16-point calibrated tape rule, and where you're supposed to be marking if you're making use of an 8-point calibrated tape rule. Like I said yesterday, I don't have the 16-point calibrated tape rule, but I have the 8-point calibrated tape rule here with me. And then you can see that it's 8 points that makes an inch. It's 8 points that makes an inch. But on the 16-point calibrated tape rule, like the name implies, 16 points that makes 1 inch. All right. So the difference between the 8-point calibrated tape rule and the 16-point calibrated tape rule is with 1 decimal point. Okay. If you have any further questions you want to ask us, please do well to drop in the comment box rather down below. Please click on the share button, like, and comment to whatsoever we're doing. Most importantly, you want to turn on the post notification bell so that you will get the notification anytime we upload the video. Once again, it's Blisszystitches. Thank you for joining us today. See you the next time. Bye.